Hello students, welcome back to my YouTube channel. This is Kashima Soni and today we are going to start the next topic in the series, chemical properties of carboxylic acid, which includes the left out portion of your esterification reactions, formation of amides, formation of anhydrides as well. Okay, so before proceeding further, I would like to apologize to all of you for not being consistent about uploading the videos from so many days, because I was busy from the last few days, which is why I was not able to continue uploading the videos as well. So yeah, that's the reason actually. And without wasting any more time, let's proceed further to the left out portion of esterification. Alright, so in the previous video we have done till this particular mechanism of esterification, and I have told you that I'll come up with the simplest esterification mechanism in the next video, and the simplest mechanism is going to be something like this. Let me show you. Yeah, so this is the simplest mechanism that you can see. What is happening? See, all of you knows that what is esterification reaction now. When your carboxylic acid heated with alcohol in the presence of concentrated H2SO4 or dry HCl gas, that is also known as Fisker sphere esterification, your esters are formed. See, you can clearly see in this particular reaction of yours, right? So this much we have clearly discussed in the previous videos also. So taking up the mechanism, the stepwise mechanism over here, you can see what is happening. First of all, the carboxylic acid will get protonated. Okay, in the presence of your acid, it will get protonated, and the protonated carboxylic acid is formed, resulting like this. Okay, now in the second reaction, what is happening? Nucleophilic attack. What it is happening? The formation of tetrahedral intermediate is occurring. So here you can see that this protonated carboxylic acid over here, in the second step you can see, let me change the color of the pen. Okay, over here you can see what is happening, that this alcohol is now acting as a nucleophile. Okay, and it is going to attack this particular electrophilic carbon. Now how it is electrophilic? See, oxygen being more electronegative is right now it is carrying positive charge, which is why it is now unstable. So it will try to retain its stability by acquiring the electron from this particular bond, C double bond O. And also oxygen is more electronegative in nature, which is why it is going to attract the shared pair of electron towards itself and making this particular carbon electrophilic. And now it is more susceptible to get attacked by this alcohol nucleophile over here. Okay, and this result in this particular structure, that is your tetrahedral intermediate, correct? And in the step 3 you can see what is happening. Actually what is happening is your proton transfer. See, now what is happening over here is proton transfer. You can clearly see in this particular reaction. Let me again change the color of the pen. Okay, so over here you can see what is happening is this oxygen is still carrying positive charge, so it will attract the shared pair of electron towards itself from this particular bond. Now what is happening is proton transfer, which is resulting in the formation of structure like this, and it will result in this particular tetrahedral intermediate. Okay, so in the previous step I mentioned that this is the tetrahedral intermediate. No, this is not. Actually this one is your tetrahedral intermediate, which is you are going to see in your step number 3. Okay, so in step number 4 you can see what is happening is your elimination of water. And now what is happening, in the presence of your H positive proton from any of your acid, which is whether it is HCl or H2SO4, what is happening, the elimination of water is occurring. Okay, so this is how this particular tetrahedral intermediate will get protonated first of all, and now what will happen, this oxygen which is carrying positive charge over here will again attract the shared pair of electron towards itself and remove the water from this particular molecule, resulting in this particular structure. Now in the step 5th, which is the last step, is occurring your deprotonation, and it results in the structure of your ester like this. So this is quite simple. Okay, this is quite simple mechanism of your esterification. You can follow this as well. So this is all about your esterification reaction. And one more thing in your particular topic of esterification is what I would like to discuss over here is that the relative reactivities of your acid as well as alcohol. See, this particular esterification reaction, its rate of esterification is very sensitive to your steric hindrance. Okay, let me write it down for you. Steric. Okay, over here I can write down steric hindrance. So your rate of esterification is quite sensitive to steric hindrance, correct? What is happening, जैसे जैसे आपके number or size of substituent around your this COOH group, जैसे जैसे आपके साइड पे यहाँ पे सब्स्टिट्यूएंट और उनका नंबर इंक्रीज होता जाएगा, उनका साइज इंक्रीज होता जाएगा, वैसे वैसे आपका एस्टेरिफिकेशन का रेट डिक्रीज होता जाएगा. I repeat, as the number and the size of substituent around your COOH group or the OH group in alcohol increases, the rate of esterification slows down, it ultimately decreases. That is another thing about your esterification reaction. So proceeding further towards the next topic, that includes the formation of amides, that is your reaction of carboxylic acid with ammonia. So this is how the reaction occurs. The carboxylic acid is reacting with ammonia and it results in the formation of your ammonium carboxylate, which is further heated to give you the product that is your amide, and water is released as such. So this is one reaction, and in another reaction you can see your carboxylic acid is reacting with primary amine and it also leads to the formation of your amide, and this one is particularly substituted amide, correct, and also your water is released as such again. So this is all about this particular reaction. So over here you can see the mechanism of your carboxylic acid reaction with ammonia. See what is happening exactly is, you can write your carboxylic acid by opening it like this, and one thing you should keep in mind while showing the mechanism of this particular reaction is that your ammonia is going to act as a base, not as a nucleophile, correct? So it is going to abstract the proton. So this is not the reaction that you are going to see. This is not going to happen where your ammonia is acting as a nucleophile, because it is not going to happen exactly. So this is the correct reaction where you can see your ammonia is abstracting this particular proton and it results into the structure of this particular ammonium salt, okay, which after heating you will get your this particular product, that is your acid amide. So that is the simplest mechanism by far and quite easy to remember, correct? So that is all about your reaction of carboxylic acid with amine, okay. Proceeding further to the next topic, that includes formation of anhydride, where your P2O5, which is acting as a dehydrating agent. So what is exactly happening is, there is actually your reaction of your carboxylic acid in the presence of your phosphorus pentoxide. Okay, so when they are heated in the presence of such kind of strong dehydrating agents like phosphorus pentachloride or phosphorus not pentachloride, pentaoxide, okay. So what is happening, your ultimately your acid anhydride is obtained by the elimination of water, by the elimination of water molecule, okay, from the two molecules of acid. That is the simplest mechanism by far. So over here you can write down plus plus water, not two molecules, plus water, okay. So water is released also, okay. So this is one reaction where you can see your two molecules of acetic acid is reacting with your dehydrating agent, the strongest dehydrating agent, which result in the formation of this acetic anhydride. So that is one way of showing your reaction of your carboxylic acid with your phosphorus pentoxide. So you can see the mechanism over here. This is quite simplest mechanism and also very easy to remember. See what is happening over here. Yeah, let me change the color. Okay, see in the reaction of your carboxylic acid with dehydrating agent like P2O5, what is happening first of all is, over here what will occur, the removal of this proton, okay. So deprotonation is occurring, and over here you can see what is happening exactly is, oxygen will be attracting the shared pair of electron towards itself, thereby carrying negative charge, and this O negative will be abstracting this particular from this carboxylic acid, this particular proton over here, okay. It will be abstracting this particular proton from this very carboxylic acid, and it result in the formation of this carbanion and this particular P2O4. It is not O5H, okay. This is the structure P2O5H. This is the structure now which is formed now. Now what is happening in the next step is the removal of your PO3 negative ion. Now what is how this is happening? Phosphorus trioxide ion removal is occurring via something like this. When your phosphorus over here is carrying positive charge, what is occurring is, now this particular structure will be acting as a nucleophile. So this is going to attack this particular phosphorus, which is electrophilic now, and after this there will be removal of your PO3 negative from this particular side, okay. This is how the removal of PO3 negative is occurring. So this leads to the structure like this, and now phosphorus is still carrying positive charge. So what is going to happen over here is, the second molecule of your carboxylic acid is going to attack your this particular molecule over here. You can see the arrow like this. And now what is going to happen? Why this particular carbon is getting attacked by this your carboxylic acid? Because it is now susceptible to get attacked by your nucleophile. Okay, that is one thing that is very clear so far. Same step that we have been repeating in the previous mechanism as well. So this is another thing, and then this leads to the removal of your another structure, that is another uh, structure, that is your HPO3. Okay, and now what is happening? It leads to the formation of your protonated anhydride, which is something like this, which after deprotonation will be giving you your anhydride. So that is the simplest mechanism, not that difficult to remember. I hope it is quite understandable to all of you. So the next thing that we are going to take up is the reactions that involve COOH group as a whole. Okay, so over here what you are going to see that your carboxylic acid and their salts will be undergoing number of reactions which involve either the elimination or decomposition of carboxyl group. So some of these reactions which are discussed below includes your decomposition or decarboxylic reaction and reduction reaction, which we are going to see in the next video that I am going to upload today only. So stay tuned and keep supporting and keep sharing and keep liking as well and keep studying. Yeah. So I hope all of the lectures are quite understandable to all of you, and if you have any sort of queries, you can mention them in the comment box over there. Okay. So yeah, that's all about it. Thank you.